Cities north of Lake Ontario draw their water from reservoirs linked to Oak Ridge's moraine. This 160-kilometer-long glacial ridge is more than 200 meters high above Lake Ontario. It's surely more subtle than the majestic Niagara Falls, but Oak Ridges tells a story far more incredible. A modern glacial flood in Iceland is called Jökulhlaup, glacial leap. Suddenly, a glacier can release its huge volume of stored water, collected on and beneath the ice. But how does Oak Ridges reveal such a story to Earth scientists? We surely learn a lot by studying the topography of the land. Directional landforms trace former glacial flow paths of ice or water across the area. We can clearly follow the north-south flow, which shifts to an east-west flow within Lake Ontario. Following this shifting flow, we now see a unique buildup of sandy sediment in 4 wedges formed west to east. In fact, as a stratified, sand and gravel moraine, it is a unique landform across Canada. Clues about Oak Ridges can unlock the mystery of these exceptional sandy ridges. The quest for hidden water resources prompted 30 years of study into the inner structure and composition of Oak Ridges. We map lake bluffs and sand pits profiles. We probe and drill underground to chart structures guiding groundwater flow paths. From the abundant underground probes and seismic surveys, we know the Oak Ridge's inner structure so well that we can map the continuity of the aquifer bodies down to the Paleozoic bedrock in 3D. Here, the Paleozoic bedrock rises sharply at the Niagara Escarpment. So, Oak Ridges might be the best-known sand and gravel, stratified moraine in the world. Most moraines are composed of till, produced from glacial movement. Ice flow on bedrock erodes varied particle sizes, boulders, gravel, sand, and clay that combine as an unsorted deposit called till, which is not stratified. Glacial meltwater produce sorted gravel, sand, silt, and clay, distinctive deposits which can build a stratified moraine. An esker, or a subglacial river, carves a tunnel and fills with stratified sediment. When water jets into a body of water, it rapidly builds a fan, at least a few hundred meters across. Oak Ridge's sediment formed in a unique way. Highly pressurized subglacial water carved a tunnel and deposited stratified sediments. The ice sheet gradient controlled meltwater flow westward along the Oak Ridges. The result, a giant esker, consists of a series of 4 large esker fan wedges, each wedge expanding westward toward and over the Niagara Escarpment. Oak Ridge's water flow was so powerful that fluvio-glacial sediments spilled over Niagara Escarpment toward Lake Erie, hence the scale of Oak Ridge's sedimentation events. And later, we will see how Niagara Escarpment also dammed glacial meltwater, trapping 80 cubic kilometers of the Oak Ridge's moraine stratified sediment, forming an enormous groundwater reservoir system. In particular, we will see how Icelandic-style meltwater floods started a series of events leading to formation of the Oak Ridge's moraine and its aquifer structure. In this series, with 3 more videos, we explore the geological framework of the Oak Ridge's moraine.